So, Dave, do you want to cover the eight wastes and take it from here?
Sure. I think, we'll go through this pretty quickly on the eight wastes. I think most folks in this webinar probably understand the eight wastes. But, obviously there are costs associated with each of these wastes. And what we're mostly going to talk about is how IIoT can help eliminate these, not necessarily get into a tutorial of the eight wastes. But things we're going to focus on today are motion, what happens on your shop floor as people are moving around to find tools to get to a new workstation, things like that, which is different than transportation, which is actually moving the goods around. Inventory can also be impacted by IIoT, and excess inventory is a waste, and sometimes that is a lever that people use to manage things within their system, that their system is not operating efficiently. And so let's say you have to be prepared for the next 3 jobs just in case something goes wrong on one because you're not monitoring your equipment. You can use inventory to kind of paper over other issues, but it has a cost, right? You reduce inventory turns, and that adds to your cost as a company. Overproduction oftentimes occurs because you don't understand how big of an impact you're going to have in quality. Overprocessing and defects. There's a PMI definition of quality, which I've always liked to use, which is the Project Management Institute, but it was meeting but not exceeding the requirements of the customer, because if you exceed, you're asking them to pay for things that they don't want. But overprocessing can sometimes, again, happen as a result of making up for other flaws in the system. Defects are pretty self-explanatory. Things go wrong with produced product, leading to scrap or rework. And rework is always a major enemy of efficient production. And unutilized talent. Trying to get people to the place where they're most effective at the right time is part of what IoT can do. That way you're, say, for example, your changeover guy, the best guy for doing machine programming for CNC, you want to get him to where he's needed for the activities at the right time and make sure that his talents are being fully utilized. So there's, ways that IoT can impact all of these. In a webinar of this length, we're going to focus on a few of these, not all. Next slide. This is just an example of a value stream map. This is one of the ways that you can try to identify some of the wastes. These things can happen at any stage here in the value map. And what you typically find when you do a value stream map is that the value added time tends to be a small percentage of the overall production time. And value added being from the perspective of the client, right? You may see value in moving paper around because, well, that's what people use to assemble or test, but that's not a value added activity for the customer. So we use this as a tool. I would assume most people here are familiar with this tool, but this is a way of identifying where the 8 wastes might exist within your process. So next slide. So rating, one of the things that IIoT can certainly help with is to eliminate waiting. You should be able to, in a modern shop floor where you have implemented an IoT solution, you should be able to understand when jobs are going to be completing, and be able to deliver that information to all the key stakeholders within your organization. So, that way you're not wondering when you have to kit the next job. You should know when you need to kit the next job because you can see the in-process status of the current job. And IoT will help you gather that information. You'll know when a job will complete because that information can be delivered very easily to all the critical stakeholders within your organization. Nice. And what you see on the right here is an output of a typical IoT platform where you can Pareto things out, but you can also verify how far along within that particular run of a product that you are, and you can do that in real time rather than continually checking to see where that job is at when it's in process. It's not ready to whip yet.
Dave, where was Sarah going to? I don't remember the exact ones where Sarah was going to talk on these topics too, because I want to make sure that she's got. Go ahead, sorry.
I was going to cover the Alejandro on the left and then hand it over to Sarah.
Okay, oh, so he's got the other two. Sorry. Okay, or other three.
Yep.
Go ahead.
So motion is another way that efficiency is lost on your shop floor. And what we showed here is there's a gentleman standing next to this machine. The only way that he can know the current status of this machine is by walking out to the machine and taking a look at it. And so this was a real life factory floor that we visited in Dallas, Texas. And this gentleman spends approximately half of his work time floating from machine to machine to gather production data and the status of jobs related to current orders that need to be shipped. And so that motion, this is a very valuable person who understands how all the machines work and understands what the issues are with each machine and how to program them. And his day, half of his day consists of walking around and gathering information that could be delivered electronically. And so with that, I will hand it over to Sarah.
Yeah, so one of the, or in my experience, I've worked for 20 years at GE Transportation, and that's a big campus. And the product that they make is locomotives, which have a lot of parts in its assembly. So there tends to be a discovery of defects at the end of the process. And in this case, people from other buildings across the campus had to travel a quarter of a mile to look at a board and understand if any of their parts needed to have repairs done. And so the solution to that was a simple visualization application that's available through mobile device. And it's also available on big screens throughout the factory where anybody can quickly look and click on a product and understand all of the defects that are required and eliminate all of that excess motion. Another form of waste is with overproduction, and that occurs when you don't have single piece flow throughout your process. And so by visualizing the manufacturing line and understanding where the bottlenecks are within that process, you can eliminate the overproduction of parts and that buildup of product as it's waiting to get processed through the next workstation. And visual dashboards are another great way that you can take data and visualize it and understand where those overproduction events are occurring, and then work process changes to help eliminate those bottlenecks and eliminate this waste. With defects, as David said earlier, having a mechanism to capture defects, you can take that information and create Pareto charts out of it, and then work continuous improvement efforts to reduce those the defective waste. There are other mechanisms that exist that help automate that through IoT. An example of that would be a vision system. With a vision system, you can set up automated inspection such that parts, as they're processed, can be placed underneath these cameras and evaluated for if it's a good part or a bad part. And in this case, you're not only identifying the defects automatically, but you're also speeding up the process to do that inspection. And that's also another place of eliminating cycle time. And this last example with IIoT is really how do you take advantage of the data in your ERP system to reduce one of the biggest wastes financially, which is inventory. And looking at the purchasing process is one of the easiest levers to reduce inventory. If I'm not ordering parts that I don't need, then I am not adding to inventory that is going to sit around. And so through an enterprise resource planning system, you can trigger the purchase orders to be launched according to the demand that's being placed on the shop floor itself. However, there is a caveat with this, and that's when your sensitivity of those purchase orders that are being placed can actually create other wastes in the other direction. So when dealing with something like a purchasing process, it's not only important to look at reducing the waste on inventory itself, but understanding what additional impact can happen on other forms of waste throughout the shop, such as waiting. If your purchase orders aren't bringing in enough material and your assembly line is waiting for parts, then it's especially important to understand and monitor what could happen from a waste perspective, establish KPIs on that, and ensure that the waste that you're eliminating in one area isn't introducing waste in another area.
Good. Thank you, Sarah, and thank you, Dave. We have the next part of the discussion here is IoT lessons learned. We're getting some questions coming in now, and I think this is also a good opportunity to open up a discussion as well between the two of you as well. So I'm going to throw you a couple curveballs. So get ready to catch these, thinking that spring training is coming up here for baseball. So here's one. The question is, I understand every case is different, but do you have any general guidelines for evaluating the relative cost of each of the waste types to allow one to address the most valuable sources of waste first? Dave, would this be something where we would apply the complexity versus value matrix approach, or would it be something different? Or that Dave will give you a chance to respond, and then Sarah, you can throw in some thoughts too.
Okay, so there are two ways to do this. One is, oftentimes IoT implementations happen in an incremental fashion. And one of the ways that you can do this is to put in a baseline system that will allow you to try to capture that cost through the IoT system to lead to future cost reductions. Just by monitoring some of the very basic things across your plant without implementing the whole system first. But what we typically do at Ectobox is, we believe strongly that oftentimes, IoT is sort of a buzzword and people want to do it, but you have to identify the business problems first. And we have a process that we go through. We call it a digital 360. It is very similar to a value stream map with a lot of extra emphasis on where data comes from and where data should go to. And so what we would do is evaluate the value stream, identify waste along the way, and try to put numbers on those. If there's not a system in place to measure some of the things that are happening on your shop floor, where some of the IoT systems will actually allow you to, for example, in process as scrap is accumulated, for example, develop a cost around the cost of quality around that scrap. But the other way to approach this, and what we prefer, is to do an analysis of the business problems and then categorize those based on complexity versus return in terms of solving them. So low complexity is typically low cost, right? So what we can typically do, and this happens, so far we have never kind of went through this process and not been able to find a low complexity, high return opportunity to focus on first by doing the value stream mapping, the digital 360 process.
And I think key to that, a key Yeah, key to that, David, also is that matrix, I think, at the end, because that really then pulls out what's valuable, which I think you touched on a little bit. And some people are familiar with that kind of process, which is what's really low complexity and high value. List those things out, score them based on the challenges you find, which, working backwards, you found those challenges through working through the value stream map. So I think it's a good process. Sarah, go ahead, and while answering, did that help answer the original question? Go ahead, Sarah. What are your thoughts?
Well, I mean, our approach to assessing the value of eliminating the waste, I think, is very similar. Understanding what does that business process look like, identifying where the key waste items are, and then evaluating those for what sort of impact would be versus what investment you would need to get the data required to solve those issues. It's very, very similar approach. I don't know that I have um, much else to add beyond that.
Yeah, makes sense. Good. So there's another question that came in. How important is having a secure and healthy network environment to the success of IoT? Um, and this is an interesting point that we've actually been running across at a number of companies that we've been touching on recently and talking with. And Dave and I can both think of the various samples. And quite honestly, that network is really important. Dave, Sarah, feel free to respond after. I'll just say a few words here. One of the thoughts that I have is around safe and healthy network for IoT. Well, IoT is about data and the massive value in data, where, assuming and expecting that you're really using that data well, which is a whole nother conversation. But you got to get that data. You got to get that data from the machines on the plant floor and from the operators and from the other systems. And that means you need a network to do that. And very often in the small and mid-sized manufacturers that are not, where they don't already have an MES or a SCADA system in place, they generally don't have an operational network, an operational technology network, an OT network. And so for the plant floor, that network is very often non-existent. And so that network needs to be set up, which is some work to do. It can be wired or wireless and take some time, but the value and the return on that is exceptional. We're working on a project right now where they're wiring up machines for the next phase of the project we're working on. And the security is really important as well, because of course cybersecurity is a big concern, a big threat. And actually, one of the companies we're working with, in fact, are going through a CMMC audit, and they're going to be changing their policies for security on the network. And we are going to be working with them to adjust the equipment that we have to pull the data and analyze the data to adjust to it. So absolutely valuable. If you want to get the data out of the machines and the people and the systems, you've got to have a solid, secure network. It's just, there's no bones about it. Dave or Sarah, any thoughts on that?
Yeah, I can recall an implementation on the shop floor of our brilliant factory. And one of the misses that we had from a project management perspective was not evaluating the wireless connectivity in all areas of the shop that needed it.
Yes. Yep.
And so we had to do some rework in implementing additional wireless antennas throughout the shop in order to eliminate those blind spots from a data connection standpoint.
Mm-hmm. Yeah. There's a company that we're working with, and we're working with a partner IT company. Warwick is an IT MSP in Cleveland, and they are doing exactly that. They are walking through with, I forget what those devices are called, walking through the plant to see what the Wi-Fi connectivity could be and to figure out where they need to put access points and all the rest of that kind of stuff, so that we can make sure that there is access there. Yeah, makes a lot of sense.
It's not enough to have it in the building. It needs to be where it's accessible to those who need it.
Yeah.
One of the other things to think about is, a lot of IoT platforms are cloud-based, and you not only have to have a robust, secure network, you also, it helps if you have the skill set to manage it and make sure that, for example, if we were to come in and try to connect directly to a machine, There's a lot of things once that connection is made that can be done remotely, which makes it cheaper and faster. And being able to provide that kind of access and understanding how to get data past the firewalls that might exist, whether it's at the, facility level or between the OT network and the IT network. And so having a good understanding of some of those things, I think, is also valuable in that it makes the implementation process easier and faster and therefore cheaper. So it's good to think not just about, do you have good connectivity everywhere, but hopefully you have a good MSP or internal team that also understands how to manage that and manage security effectively and easily.
Yeah, good. All right, so here's if those were curveballs, here's a really nice breaking ball or a sinker that somebody's throwing in. Yeah, I'm going too far with the baseball analogies, but go with it, please. So can you do production smoothing across a series of CNC machines? And here's the example. If there's a row of horizontal CNC machines connected to a pallet pool, can you recommend moving operations from one machine to the next so that each part is being passed efficiently to the next machine? And here's an example, a more specific example. Move a drilling operation to a machine from machine two, moving a drilling operation to machine two from machine one so that the parts cycle to the next machine. Now, you might need some clarification around that, and this gets into very specific context and situational kind of things. But off the top of your heads, Dave, Sarah, any thoughts on that question?
I think that IoT can help inform that process. That's really a scheduling challenge, which IoT is not necessarily a scheduling system, but the information gathered through IoT so that you can understand current loading and current status of a job, whether it's half done, 3/4 done, or completely done, would be valuable to the scheduling process that would enable you to do that. You would need that information in order to be able to level production as you're discussing. I don't think, the scheduling system is not necessarily part of the IoT solution, but I think the IoT solution would feed critical information to the scheduling in order to enable that to happen.
It informs the scheduling. So the idea is when you're getting into the idea of a digital factory, which IoT is one of the big pieces of the puzzle to enable that kind of stuff, then at that point, because you're pulling data from machines and people and operations, and then you're sharing that data across the organization, then everybody knows what's going on at all times relevant to their position. Data shared across the organization, data can be analyzed, and then you can get into a lot of other viable ideas beyond that. And with that said, then the data from the plant floor, not just IoT, but from the machines and from their operators, truly should be informing scheduling, potentially at real time as well. Hopefully that helped answer the question. So for sake of time, let's move on to the last slide, the last topic, which is IIoT lessons learned. I'll throw out a couple of these, and then Sarah, Dave, feel free to jump in for a couple others that we added that you added to this list when we were preparing for this conversation. One of the things that I like to talk about is the idea of defining the business outcomes and requirements in data, number two, and not trying to start with the technology first. And the story I often tell on this is there's a big publicly held company out there, several $billion in revenue, and their CEO went out and talked with Deloitte and Touche and said, how can I make our company better? Deloitte and Touche or somebody like that, I forget who it was, turned around and said, IIoT. And so the CEO then said, go forth and IoTize to the company. And these engineers said, yes, sir, we'll try to figure out what we can do. And they immediately then got into working on the sensors and the small edge devices to gather the data and trying to figure out how much data can we gather. Let's try to get as much as we can. and they got themselves wrapped around the axle that they never really made any progress. And then some management got involved, some good, reasonable, smart people, and said, wait, we've got to take a different approach. We have to start to figure out what kind of problems there are to solve first. Let's take one of those problems, let's create a hypothesis around it, let's figure out what data or what information we need to solve that hypothesis. Then let's figure out how much data or what data we need to convert into valuable information. And then finally, we get into the technology. What technology do we need to get that data? That's the process of going step down from the top to bottom rather than from bottom up. And that's something critical that I still hear to this day, even earlier this week, talking with a couple of manufacturing engineers. I just want all the data. Let's stop and think about that.
There's a cost.
Yeah, there's a cost. Yes, exactly. Sarah, do you want to take on one or two of these?
Yeah, I mean, I think I want to highlight the becoming a data-centric company. I think, in the past in manufacturing, there was a lot of dependency on expertise, and those domain experts that just understand the processes through and through is there's less of that in the industry. Data is going to become incredibly more important to be replaced. So learning how to increase the acumen of the people everywhere from the shop floor up through the leadership to become data centric is a really important component of getting the value out of all of the data capture that you're able to do through these technologies.
Yep. Dave, you want to tackle one?
Yeah, I think, I want to follow on with one of the things you were talking about, which is, understanding upfront what business problem you're trying to solve. I'm thinking of a factory that Kevin and I visited where we went to talk to the gentleman about an IoT platform, and his thoughts were, well, I have reams and reams and reams of data,
Yes.
and I really want to try to get something out of the data I already have. But the data that he had, while there were, if you put it on paper, you'd probably fill a giant room with it. It contained 95% worthless information, which made it very difficult to think about what the valuable information was. And there was information missing because the data gathering wasn't based on solving a business problem, right? And that's what that headline up there is really about, which is solving real problems versus just implementing technology. Just gathering, as Kevin said a minute ago, all the data, too much data is almost the same as no data, because you can't find the valuable stuff in there if you're not trying to solve a business problem. So you really have to understand what you're trying to solve up front, so that the data is specific and you're not trying to swim through an ocean of data to find the one little nugget of something that was going to be really valuable, right? So it's really important to start with the business challenges.
Yep, fair, good. All right, to respect everybody's time, we are over by a few minutes. So with that said, I'd like to thank Dave and Sarah for being on this call. Bernie, Mark, Joe, thank you for your questions. I really appreciate it. Those are really good questions. And if anybody has any further questions, feel free to reach out to any of us. Here's our contact information here. And also a huge kudos to NWIRC, Michael, Molly, Lori, Bob, and everybody else there for the work that they're doing for all the manufacturers in Northwestern Pennsylvania. It's a huge benefit, really helps manufacturers a lot. And they're a great resource to work with. Michael, that's everything.